boards, pero fortunately US law. However, for surface chemistry and colloids, lagi itong lumalabas sa boards. Merong laging ITABs regarding these topics, okay? So, are you guys? I hope you are. So, let's start, okay? Now, let's start with photochemistry. So, what is photochemistry? Now, a photochemical reaction, it occurs upon the absorption of visible or ultraviolet light. Okay? So, yung mga reactions na to, they will require light para magkaroon tayo ng products. Okay? So, but molecules, when they absorb light, they will change to their excited states. Okay? So, the physical and chemical properties of the molecules will be different in their excited state. Okay? So, photochemistry in general is a branch of chemistry that deals with rates and mechanisms of chemical reactions in the presence of light. Okay? So, in general, UV light, visible light, or infrared radiation ang involved na light in photochemical reactions. So, what can we say? Sunlight, therefore, plays an important role in photochemical reactions. Okay? For example, guys, here on the left, we have a typical photochemical reaction, right? So cool. And other examples of photochemical reactions include photosynthesis, formation of ozone layer, kaya dito, guys. This is the reaction for the formation of ozone layer, skin cancer due to ultraviolet rays, and the formation of photochemical smog. Okay? Now, in photochemistry, we can discuss the photoelectric cells. Now, photoelectric cells, they will measure light intensity using the photoelectric effect. Okay? So, when light strikes a metal surface inside the cell, di ba nag-eject, nag-emit tayo ng electrons. Now, the emitted electrons will generate an electric current. So, yung current na yan is being measured by your ammeter. Okay? And the current is directly proportional to the light intensity. Okay? Now, these are the laws that are usually explained in photochemistry. Okay? So first, we have Grotthuss-Draper law. So according to Grotthuss-Draper law, only the light that is absorbed by a substance ang pwedeng mag-cause ng chemical reaction. Okay? So yung light na hindi na-absorb, syempre wala siyang effect sa chemical reaction. Then second, we have the Stark-Einstein law of photochemical equivalence. So according to this reaction, for each molecule involved in a reaction, only one particle of light, which is photon, is absorbed. So yung single photon na yan gives the molecule enough energy to react and form a product. Again, for each molecule involved in a reaction, only one particle of light called a photon is absorbed. That is according to the Stark-Einstein law of photochemical equivalence. Now, in photochemistry, we can calculate for the quantum yield. So the quantum yield or quantum efficiency is the number of molecules that react or are formed for each photon of light absorbed. So it shows us how efficiently na-absorb ang light and how, or in other words, guys, okay, quantum yield, it shows us how efficiently absorbed light causes a chemical reaction. So the quantum yield is equal to the number of reacted or formed molecules divided by the number of absorbed photons. So if you have a high quantum yield, the quantum yield is greater than 1, right? Meaning the reaction is very efficient. Okay? More than 2 molecules decompose per 1 photon. Meaning that, guys, many molecules will react for each photon absorbed. Then if you have a low quantum yield, then the quantum yield or quantum efficiency is less than 1, where less than 1 molecule decomposes per 1 photon. Okay? Ayan. So, 0.0001 mole of a substance decomposes when irradiated with light of 5,000 angstrom wavelength. How many photons are absorbed during the reaction? Given that the quantum efficiency is 10%. So guys, we simply have to find the molecules that decompose first, and that is equal to 1 times 10 to the power of negative 4 moles of the substance times 6.02 times 10 to the power of 23 molecules. So guys, tandaan lang, 6.022 times 10 to the power of 23 molecules is just equal to 1 mole. So you can cancel mole, and then you'll get the number of molecules that decompose, and that is equal to 6.022 times 10 to the power of 19 molecules. Now, we can calculate for the number of absorbed photons through this equation for the quantum yield. So quantum yield is equal to 4 molecules divided by absorbed photons. So absorbed photons is equal to the 4 molecules divided by the quantum yield. So 6.022 times 10 to the power of 19 molecules divided by 0.10. Okay, guys, dapat 0.10 yan. Kindly correct this in your manual. Again, dapat 0.10. So apologies guys for the correction. Again, dapat 0.10 yan because your quantum efficiency is 10%. Therefore, dapat 0.10 ang quantum yield niya. Okay, I hope that's clear, guys. So solving, we get the absorbed photons is 6.022 times 10 to the power of 20. 6.022 times 10 to the power of 20 photons. Okay, that's how you solve. So again, kindly correct this on page P62. Now, let's move on to the next part of our special topics crash course. This is the surface chemistry. Now, surface chemistry, guys, it is a branch of chemistry that focuses on the study of the properties and behaviors of surfaces and interfaces between different phases, such as the solid-liquid, solid gas, or liquid-gas interfaces. So, guys, surface chemistry is very helpful in determining the adsorption processes, right? So, guys, alam niyo ba yung mga N95 masks? Naalala niyo ba yan during the COVID era, the pandemic era? Okay. Kasi, guys, actually, yung N95 masks, di ba? They were so helpful back then because they help eliminate viruses and other harmful microbes. So, it also allows us to breathe only virus-free air. Now, how do the N95 masks do this? Okay. So, it all comes down to the phenomenon known as adsorption, which is widely studied here in surface chemistry. So, N95 masks, guys, they are made of multiple layers of filters and membranes that are able to adsorb viruses and other harmful microbes. Okay? So, yun yung goal ng surface chemistry na pag-aralan ng adsorption. And ang dami talagang applications ng adsorption. Diba? Now, what is adsorption? So, we know, guys, the definition of absorption, right? As in yung may B. So, absorption, it refers to the transport of particles through an interface. So, nasa bulk siya. Diba? While adsorption naman, nag-a-adhere ang particles sa surface ng solid. Again, iba yun sa adsorption. Adsorption, add, as in yung D, it involves the accumulation of molecules at the surface rather than in the bulk of a solid or a liquid. So, meron kang buildup of molecules at the surface of a solid or a liquid rather than in the bulk of your solid and in your liquid. Okay? So, guys, meron tayong tinatawag na adsorbate and adsorbent in adsorption. So, adsorbate, it is the molecular species or substance, okay, na mag-concentrate or mag-accumulate sa surface ng adsorbent. So, when we say adsorbent, it is the material on the surface of which the adsorbate molecules get adsorbed. Okay? So, since adsorption, guys, it is a surface phenomenon, as the surface area of your adsorbent increases, edi yung amount of adsorbate getting attached to the surface of the absorbent also increases. Therefore, adsorption increases as surface area increases. Okay? Meron din tayong tinatawag na desorption. Now, desorption is the process of removing an adsorbed substance, that is your adsorbate, from the adsorbent, or from the surface on which it is adsorbed. So, let's differentiate adsorption from absorption. So, when we say adsorption, again, this occurs when the concentration of another material on the surface is higher than in the bulk. So, basically, guys, yung mga solute nyo mag-adhere siya sa surface. Hindi sa bulk. Absorption naman, yung substances molecules, they will equally disperse throughout the bulk of a liquid or a solid. Okay? That's why we call adsorption as a surface phenomenon and absorption as a bulk phenomenon. Again, this figure will summarize to us the differences between adsorption and absorption. So when we say adsorption, let's say in a liquid to solid interface, the molecules from a liquid will stick to the surface of a solid, as you can see here. So again, this only happens only on the surface of the solid. So for example, guys, meron kang activated charcoal. Tapos, ididip mo siya sa dirty water. So, yung mga contaminants ng dirty water mo, magsistick siya sa surface ng activated charcoal. Okay? Now, we have here on the right is the absorption. So, absorption naman, this occurs usually in gas liquid interfaces. So, the gas molecules in absorption, they will get dissolved and they will go inside the bulk of the liquid. Okay? So, it occurs throughout the entire volume of the liquid and not just the surface of the liquid. So, for example, guys, di ba nagbukas ka ng Coke? Okay? Yung CO2 niyan, yung carbon dioxide, it will escape from the liquid. Okay? Kasi, na-absorb na, di ba, yung CO2 dun sa liquid mo. So, pag binuksan mo yan, hindi talabas na ang CO2. Okay? I hope that's clear, guys. Now, let's describe the thermodynamics of adsorption. So, now, here we have the various thermodynamic properties which describe adsorption. So, first we have enthalpy, delta H. So, during adsorption kasi guys, there is always a decrease in the residual forces of the surface. Okay? So, there is a decrease in the surface energy na nag-appear as heat. Okay? So, habang nangyayari yung adsorption na yan, heat is being released. Therefore, adsorption is an exothermic process. Therefore, the sign of the enthalpy of adsorption, it is negative. Okay? Now, what can we say about entropy? So, with adsorption, the degree of randomness of the particles, it will decrease. Okay? As the adsorbate particles are bound to the surface. So, guys, diba, mayroon mga adsorbate particles na mag-adhere sa surface mo. Now, the degree of randomness, the disorder of the particles, it will decrease. Kasi syempre guys, pag bound na sila sa surface, pag nag-adhere na sa surface, okay, their freedom to move is being restricted. Therefore, entropy decreases. Okay? Next, for a reaction to be spontaneous guys, diba, syempre delta G must be less than 0. So, it is spontaneous when heat is being released. Again, spontaneous lang, based on this equation, ang ating adsorption reaction. If delta H is great, or if it is more negative than T delta S. Okay? So, meaning guys, kailangan mo ng large amount of heat to release in order to overcome the negative T delta S. Okay? So, ang spontaneity condition ng ating adsorption ay dapat, okay, the heat that will be released during the adsorption, it must outweigh the loss in disorder. Okay? Ganun lang. Now, as adsorption continues, guys, actually, the delta H, it becomes less and less negative. Okay, syempre guys, kung mas dumadami yung mga particles na nag-adhere sa surface, okay, there are fewer empty sites. Fewer empty sites for more adsorbate particles to adhere to. Therefore, less heat will be released, and then that will result in a delta G equal to 0. Okay? So, at that point, guys, kapag, for example, lahat ng sites ng inyong adsorption surface ay na-fill na, okay, delta G may reach 0, which is an indication that equilibrium has been attained. Okay? Recall your thermodynamics, guys, with regards to these concepts. Okay? Now, there are two types of adsorption. These are physisorption and chemisorption. So, physisorption, it involves the weak physical interactions between gas molecules and the surface. So, for example, here, guys, the gas molecules, they will weakly adhere to the surface of a solid through van der Waals forces. Okay? So, it generally occurs at low temperatures and it is multi-layer adsorption. Okay? So, for example, guys, here, for example, dust molecules, they will accumulate at the walls or at the windows of a car, right? That is what we call a physisorption or physical adsorption. So, these are the common features of a physisorption process. First, it lacks specificity. So, a given surface of an adsorbent, it does not show any preference for a specific gas because, guys, van der Waals forces, they are universal. So, they don't have any preference for a specific gas. Next, the amount of gas absorbed by a solid depends on the nature of the gas. So, the nature of the gas will influence the amount of gas na ma-absorb ng solid. Okay? So, yung mga easily liquefiable na gases, they have a higher critical temperature, right? So, they are readily absorbed. Okay? So, for example, 1 grams of activated charcoal absorbs more sulfur dioxide, SO2, than CH4. Okay? Because SO2 has a greater critical temperature of 630 Kelvin than methane. Si methane naman, 190 Kelvin. Okay? Next, physical adsorption of a gas by a solid is generally reversible. Okay? So, by a solid, again, the physical adsorption of a gas is reversible. So, general trend naman for physisorption is that more gas is adsorbed when pressure increases. Okay? So, guys, when you increase pressure kasi, the gas volume will decrease, thereby favoring adsorption. Okay? So, we know that adsorption releases heat, right? It is an exothermic process. Therefore, adsorption happens more easily at low temperatures. So, when the temperature increases, the amount of gas adsorbed decreases. Okay? And lastly, guys, the extent of physisorption mag-increase siya with an increase in the surface area of the adsorbent, as I said earlier. Right? Because finely divided metals and porous substances, syempre guys, diba, finely divided sila, therefore they have larger surface areas. Therefore, they are good adsorbents. Okay? Ayan. And then we have what we call chemisorption. So, chemisorption naman involves stronger chemical bonds. And this often leads to irreversible adsorption. Okay? So, in chemical adsorption or chemisorption, the gas molecules or atoms of the adsorbate are held to the solid surface of the adsorbent by chemical bonds. Kaya siya stronger than physisorption. Okay? So, yung mga chemical bonds na involved in chemisorption, they may be covalent or ionic bonds in nature. Okay? So, unlike physisorption, chemisorption occurs at generally high temperatures and is monolayer adsorption. Okay? And chemisorption, guys, it involves a high activation energy. Ang tawag sa kanya, activated adsorption. So, unlike physisorption, chemisorption is more specific. Okay? Nangyayari lang siya if there is a possibility of chemical bonding between adsorbent and adsorbate. Okay? So, for example, yung hydrogen, it is adsorbed by transition metals because of hydride formation. Okay? So, very specific, right? The transition metals, they have to adsorb hydrogen. Yun yung tinatawag na chemisorption. Next, again, chemisorption, it usually is irreversible in nature because it involves compound formation. Okay? So, like physisorption, chemisorption, it is also exothermic. Okay? So, masasabi natin guys that chemisorption increases with increasing temperature. Okay? Bakit naman guys? Bakit this time directly proportional ang temperature kay chemisorption? This is because there is a high activation energy involved with chemisorption. Kaya it is generally slow at low temperatures. Okay? Kaya like most chemical reactions, kailangan guys na high ang temperature in order for chemisorption to occur more. Like physisorption, chemisorption also increases with an increase in the surface area of the adsorbent. Okay? And lastly guys, as chemical bonds are formed in chemisorption, syempre yung enthalpy of formation will be high. Ayan. So this table here summarizes the general differences between physisorption and chemisorption. Again guys, physisorption arises from weak van der Waals forces. Chemisorption naman, it arises from strong ionic or covalent bond formation. So more selective ang chemisorption than physisorption. We have a large sheet of adsorption for chemisorption. Okay? Again guys, because here chemical bonds are being formed which are stronger than the weak van der Waals forces. Okay? And in general guys, irreversible ang chemisorption. Okay? And tandaan lang na for physisorption, okay, temperature and the adsorption is inversely proportional, while for chemisorption, as temperature increases, the adsorption also increases. Okay, so magkaiba sila ng trend, guys. And then for effect of pressure, so as temperature increases, physisorption increases. While for chemisorption, pressure has no effect. Okay, and another distinct features of physisorption is that multi-layer adsorption occurs, while for chemisorption, only a monolayer adsorption is occurring. Okay, so a common example of physisorption is oxygen or hydrogen adsorbed on charcoal, so that involves weak van der Waals forces, while chemisorption of hydrogen on a nickel surface involves the chemical bonds between hydrogen and nickel. Okay? So, tandaan lang yun, guys. Ayan. So, in general, these are the factors that affect adsorption. So, first is the nature of gas, which is your adsorbate. So, its effect on adsorption is increasing for gases that are easily liquefied. Okay? So, pag easily liquefiable yung gases nyo, syempre guys, mas madali siyang adsorb ng solid. Okay? Therefore, gases with higher critical temperatures are adsorbed more. So, that's why carbon dioxide is more adsorbed than H2. Next, in terms of the nature of the solid, which is your adsorbent, so there is an increasing absorption with the increasing surface area of your adsorbent. Okay? So that's why finely divided solids, such as activated charcoal, clay, nickel, cobalt, they have more surface sites where the adsorbate can adsorb or adhere to. Next, in terms of temperature, so again with physisorption, physical adsorption, it decreases with increasing temperature. Pero chemical adsorption, so generally, it increases at first. So as temperature increases, chemical adsorption increases. However, it attains a certain maximum. Kaya it will then eventually decrease. Okay? So again, the reason for chemisorption, that's why it has a different trend because it needs activation energy. Okay? And then lastly, in terms of pressure, there is an increasing adsorption with increasing pressure for physisorption. Okay? Bakit? Because guys, at constant temperature, when we add more pressure, meaning more gas molecules ang ma-adsorb into the liquid based on the Le-Chatelier's principle. Okay? So guys, bakit na exactly nagdi-decrease ang adsorption, ang physical adsorption with increasing temperature? Again guys, we have in physical adsorption weak van der Waals forces. So kapag nag-increase ang temperatures guys, the particles, they will have more kinetic energy, they will move faster, making it harder for these weak forces to hold them on the surface. So the absorption will decrease as temperature increases. Okay? Ayan. So again, the larger the surface area of the adsorbent, the greater will be the number of sites available for adsorption as shown here, right? O, tingnan nyo guys, pag finely divided ang inyong adsorbent, there are more sites available for the adsorbates to adhere to. So mas maraming sites available, di ba? As you make it more finely divided. Okay? So dahil dito guys, yung powdered charcoal, that is much more effective in absorbing compared to solid charcoal. Okay? Again, powdered charcoal is more effective. Okay? So guys, these show the adsorption isomers for physisorption and chemisorption. So sabi nga kanina, as the temperature increases, adsorption decreases for physisorption. Pero for chemisorption, adsorption increases and then decreases. So again, let's discuss one by one bakit nangyayari yun. First of all guys, bakit exothermic ang adsorption? Diba? Pag yung gas or liquid particles nyo nag-stick sa solid surface, new bonds or forces form between the adsorbate and the surface. Diba? Now, forming these bonds again releases energy as heat. Diba guys? Diba sabi ko dati bond formation is exothermic. Okay? Again, that is why exothermic causes ang adsorption. Now, again, bakit physical adsorption decreases temperature? Again, because as temperature increases, the particles, they have more kinetic energy, kaya gagalaw sila ng gagalaw, making it harder for the weak forces between the adsorbate and the adsorbent to be held together. Okay? So, syempre, sobrang malikot yung mga particles nyo, hindi na siya kakayanin hold down ng surface nyo. That's why adsorption or physisorption decreases as temperature rises. Now, what does chemisorption first increase, then decrease with temperature? So, guys, tandaan, chemisorption involves forming strong chemical bonds, diba? Between the adsorbate and the surface. Now, this process, syempre, kailangan din ng activation energy. Now, at low temperatures, guys, not enough energy is available for the bonds to form easily, diba? Kasi, syempre, kailangan mo ng high activation energy. So, the chemisorption is low at low temperatures. So, kailangan mong increase onte ang temperature para magkaroon ka ng chemical adsorption. Okay? In order for you to have enough energy for bonds to form between the adsorbate and the adsorbent. Okay? So, as temperature increases, more molecules gain enough energy to overcome the activation energy barrier. Ito. Okay? That's why chemisorption increases. However, pag tinaas pa yung temperature, the heat starts to favor the reverse process, which is the desorption. Okay? So yun yung nangyayari. Pag in-increase mo pa yung temperature, desorption na yung nangyayari, which causes the breaking of bonds between the adsorbate and adsorbent and causes chemisorption to decrease again. Pababa ng pababa. Okay? Ganun ang nangyayari, guys. Okay? So again, guys, when pressurizes, more gas molecules are pushed towards the surface of the absorbent. Imagine you guys, nag-push kayo ng piston dyan. O syempre, pinipilit natin yung molecules na dumikit sa surface. Okay? That's why, as pressure increases, as shown here, adsorption also increases. Okay? So, based on that lang adsorption, it increases until the surface is fully covered. So, syempre, may maximum lang na sites available for adsorption sa ating surface or adsorbent. That's why, meron tayong maximum pressure na ma-attain dito. Okay? Now, we have what we call the adsorption isotherms. So, the adsorption isotherms, they have been used extensively in research on environmental protection and adsorption strategies. Okay? So, these isotherms, they will describe the relationship between the amount of gas adsorbed on a solid adsorbent surface and its pressure or concentration at constant temp. So, two of the most common approaches for determining a material's adsorption capacity ay ang Langmuir and Freundlich isotherms. Again, the goal of our adsorption isotherms is to determine a material's adsorption capacity. So, this table summarizes here the description, the basic description of our Langmuir and Freundlich isotherm. So, the Langmuir isotherm it assumes that the adsorbed gas forms a monolayer on the surface. Again, the keyword for Langmuir is monolayer. So, yung adsorbed layer na yan is uniform across the surface. Again, uniform. And it assumes that there is no interaction between the neighboring adsorbed molecules sa monolayer mo. And Langmuir is only applicable to low pressure conditions. So, ang main trend dito kay Langmuir is that as concentration of the adsorbate increases, the adsorption Q will increase until it approaches a maximum value. So, adsorption is Q. It will increase with increasing the concentration of the adsorbate until it approaches a maximum value, Q max. Okay? Now, when we say Freundlich isotherm, it is valid only up to a certain saturated point. So, hindi siya suitable at higher pressures, and it only applies to heterogeneous surfaces because it assumes that the surface is not uniform. Okay? And it assumes that there are different adsorption strengths at different sites. So, please take note of that again. In Freundlich isotherm, it assumes that there are different adsorption strengths at different sites. So, for example, yung surface nyo ganito, lubak-lubak. Okay? So, yung mga surface na yan, they have different adsorption strengths. Okay? And adsorption Q increases with the concentration of the adsorbate, but not linearly as well. Okay? Now, let's go to Langmuir isotherm. So, Langmuir, he discovered that two opposite processes are taking place during adsorption. So, this is number one, adsorption of the gas molecules on the surface of the solid, and number two, the desorption of the adsorbed gas molecules from the solid surface. Okay? So, this is what the Langmuir isotherm looks like. Okay? Again, as concentration of the adsorbate increases, the adsorption capacity Q or adsorption Q increases as well until Q max is attained. Ayan. And these are the equations involved for a Langmuir isotherm. So, describe muna natin ano yung mga usual features ng ating Langmuir isotherm. So, it describes the fact that the gas molecules, they will act like an ideal gas. So, meaning yan guys, yung mga gas molecules na nasa surface, hindi sila mag-interact with each other. So, they will just follow the simple gas laws that we know. Next, in a Langmuir isotherm, the solid surface is uniform. Meron kang specific number of spots where molecules can stick. So, each spot can hold only one gas molecule. Again, each spot can only hold one gas molecule. Okay? So, this isotherm really fits well with chemisorption. Now, here, the adsorption rate is equal to the desorption rate. So, meaning nito guys, yung number of molecules na dumidikit sa surface, it is equal to the number of molecules na umaalis sa surface. Para balance lang yung system. And lastly, there is no overlap between adsorbed molecules. Okay? Separated sila throughout the surface. Okay? So, these are the equations involved. Okay, so first we have Q is equal to Q max KLC over 1 plus KLC. Okay? So here guys, we have Q. Again, Q is the amount of adsorbate adsorbed per gram of adsorbent at equilibrium. So, ang units ng ating QI in terms of mg over g. Okay? And then Q max here is the maximum adsorption capacity. So, same lang ang kanyang units. It is mg per gram. So, it describes how much can be adsorbed when the surface is now fully covered. Now, C is the concentration of your adsorbate. So, ang units yan ay mg per liter. So, pwede rin guys, meron kang pressure, depende sa given na equation sa inyo. And lastly, KL here, it is the Langmuir constant. It represents the affinity or the strength of the binding between the adsorbate and the surface. Again, this is just a concept that describes the strength or the affinity of the adsorbate to the surface of the adsorbent. Okay? So, pag mataas ang KL nyo guys, ang Langmuir constant, it means that there is a strong binding force between the adsorbate and the adsorbent surface. Okay? Now, we have here another form of our Langmuir isotherm equation. Ito yun. Okay? So, what is theta? So, theta is equal to Q over Q max, which represents the fraction of the surface covered. So, Q, basically guys, so this theta here represents the number of sites occupied divided by the total available sites. Ganon. Okay? So, ganon din. That's another way to view the fraction of surface covered. So, that is the number of sites occupied divided by the total available sites. Okay? Next, we have what we call the Freundlich isotherm. So, the Freundlich isotherm equation is another model used to describe how substances or the adsorbates stick to adsorbates. Okay? To adsorbents. Okay? Pero mas flexible siya compared to the Langmuir model. Bakit? Kasi it is very applicable to the heterogeneous surfaces. Okay? So pag sinabi natin heterogeneous surfaces, we have surfaces with different types of sides. Okay? So again, guys, this is the graph for the Freundlich isotherm. Okay? So that is log P versus log Q. So log Q ito, guys. Log Q. This is log Q. Okay? Where the slope is 1 over N. So Q again is your adsorption capacity, where it describes the amount of adsorbate na na-adsorb per unit mass of adsorbent. Okay? And then the Qmax. Again, kanina yung Qmax. Dito walang Qmax, right? Okay. Next, we have the concentration of adsorbate. Okay, pwede rin in terms of pressure. So this P here is the pressure of adsorbate in gas phase. So pwede rin guys in terms of P or in terms of C ang ating Freundlich isotherm equations. And here we have the Freundlich current constant Kf, and it describes it is related to the adsorption capacity. Now, what is 1 over N? Yung slope. Now, the 1 over N, it describes the intensity of the adsorption or how favorable the adsorption process is. So, tandaan lang guys, 1 over the N must be greater than 1, where the normal range of 1 over N must be between 0.7 to 1. Okay? So, guys, again, ang typical range for 1 over N must be equal to 0.7 to 1. Okay? Because this normal range here reflects good adsorption. Good adsorption. Okay? It represents strong but realistic adsorption. Okay? Kasi beyond the range, guys, so for example, what if 1 over N is less than 0.7? Okay? This suggests too strong or non-physical adsorption. Meanwhile, if 1 over N is greater than 1, it may imply poor surface affinity. That's why normal range of 1 over N is between 0.7 to 1. Okay? Again, these are the equations involved. So we can simply have a linear graph for our Freundlich isotherm where log C can be X, log Q is Y, or log P is X, and your slope is 1 over N. Again, guys, 1 over N, it describes how favorable the adsorption process is, okay? Or the intensity of adsorption. So guys, going back to Freundlich isotherm, one thing to take note is that one of the major drawbacks ng ating Freundlich isotherm is that hindi niya kayang explain yung extent of adsorption at high pressure of the gas. Okay? Ayun. Now let's summarize the types of adsorption isotherms that we have discussed. Again, the Langmuir isotherm, it is valid mainly for chemisorption, because here you have strong chemical bonds. For Freundlich naman, it is valid mainly for spaciosorption. So here you have weak physical forces such as van der Waals. Next, in terms of surface type, for Langmuir isotherm, it assumes a homogeneous surface, okay, where all adsorption sites are identical. While for a Freundlich isotherm, it assumes a heterogeneous surface, where the sites they vary in strength and mass. Okay? In terms of layer form naman, for Langmuir, it forms a monolayer. So only one molecule lang per site ang ma-adsorb. So wala tayong stacking na nagaganap. Then for Freundlich isotherm, it can form multilayer. So molecules can adsorb over others indirectly. And then in terms of molecular interaction, for Langmuir, there is no interaction between adsorbed molecules. Pero kay Freundlich naman, it can allow some interaction, but it is not directly modeled, guys. Okay? It is only implied because in this case, for Freundlich, we have a heterogeneous surface. Okay? And then in terms of processes involved, so Langmuir, it involves both adsorption and desorption na in equilibrium. Diba? Adsorption rate is equal to desorption rate. However, for Freundlich, it only involves adsorption. So wala kang desorption term sa kanyang model. And then in terms of pressure, again, Langmuir, it is only applicable at low pressure and limited at high. And Freundlich naman, again, it is not valid at very, very high pressure. Okay? And in terms of adsorption behavior, for Langmuir isotherm in general, the adsorption capacity decreases then levels off at a certain maximum adsorption capacity. Then for Freundlich isotherm, the adsorption capacity decreases non-linearly with concentration. There is no upper limit. It just keeps increasing. Okay? Now, what are the applications of adsorption? So first, we have in terms of fixed bed adsorption columns. So in fixed bed adsorption columns, a gas or a liquid na tinatawag nating feed, that mag-flow siya to a column filled with an adsorbent. Okay? So yung adsorbent na yan, solid siya na mag-capture ng particles. Now, yung feed, it contains the adsorbate. So, yung adsorbate na yan, yun yung substance na gusto nating i-remove or i-collect using the adsorbent. Okay? Na nasa column. Now, as the feed passes through the column, yung adsorbate na yan, magsistick yan sa adsorbent. And it gets removed from the feed. So, after some time, na nilagay mo yung feed throughout the column, okay, the adsorbent, it will become full or saturated na ng mga particles. It cannot hold any more adsorbate. So, at this point, may introduce tayo na liquid, tinatawag nilang regenerating solution, okay, to wash off or recover the adsorbent. So, yung adsorbent, may reason siya. After na-wash off ng regenerating solution, yung adsorbent na dumikit sa adsorbent mo. So, very usable ang adsorbent in this case. Next application. So, adsorption plays an important role in the adsorption of nitrogen and hydrogen gases onto the surface of the iron catalyst. Okay? So, on the surface, guys, okay, yung N2 and H2 bonds, they will break. Kaya, yung mga atoms yan, they will become more reactive. Now, on the surface, yung activated atoms yan, they will combine on the catalyst surface to form ammonia. Okay? So, then ang ammonia synthesis. Now, the formed ammonia molecules, they will be then released or desorbed from the surface and into the gas space. Ayan. Next application we have here, again, the adsorption of ethylene on nickel surface. So, ito again, as another key step of catalytic hydrogenation. So, yung ethylene, convert siya into ethane using hydrogen 2H2 in the presence of a nickel solid catalyst. So, ano nangyayari? Yung ethylene, di ba, ma-adsorb siya sa surface ng nickel. The pi electrons in the CC double bond of ethylene, ito. Okay? Now, yung pi electrons, ayan, mag-interact siya sa empty orbitals ng nickel atoms. Again, yung nickel nyo, yun yung solid surface. So ito na yung tinatawag na chemisorption, di ba? Again, the electrons, pi electrons of the ethylene will interact with the empty orbitals on the solid nickel atoms. Okay? Yun na yung tinatawag na chemisorption. So, ano naman nangyayari kay H2? So, si H2 din guys, ma-absorb din siya sa nickel surface. Okay? Now, on the surface, H2 molecules, it will split into hydrogen atoms. Okay? Now, yung adsorbed hydrogen atom sa surface, mag-react siya sa adsorbed na ethylene. Ito yung letter C. Okay? Adding across the double bond to form ethane. Okay? So, ang final product natin guys is ethane. And it will detach from the nickel surface or ma-desorb siya and it will leave the system. Okay? So, later in your organic chemistry, you will learn about catalytic hydrogenation. Okay? Ayan, now let's move on to colloids. So, colloids, these are mixtures that have dispersed particles larger than the solutes, but smaller for the mixture to become heterogeneous. So, meaning guys, ito yung gitna ng inyong solution and your suspension. Okay? So, here, the dispersed particles, they are evenly distributed throughout the dispersion medium. So, for example, ang dispersion medium yung ay liquid, okay? Evenly distributed yung particles na yan, and they will not settle at the bottom. So, for example, here we have a salt solution. The particles of a salt solution has particles with a size of less than 1 nanometers. For suspension naman, diba, yung sa suspension natin, we have particles settling at the bottom. So, for example, sand and water. So, the particles in suspension, their size is more than 1,000 nanometers. However, for colloids, guys, nasa gitna yan ng suspension mo. So, for example, we have here milk. So, ang kanyang particles are dispersed or evenly distributed throughout the liquid. Okay? And the particle size is 1 to 1,000 nanometers. Now, how can we determine a colloidal mixture? That is through the Tyndall effect. So, for example, mag-flash ka ng flashlight sa mixture mo. Okay? So, mangyayari guys, for a solution, okay, syempre, hindi siya magpapass through lang yan. Di ba? However, for a colloid, okay, light will not completely pass through. Kasi yung mga dispersed particles mo, mas malaki compared to the particles of a solution, right? Therefore, ang mangyayari is a scattering of light. Okay? Again, you have scattering of light. Therefore, you have Tyndall effect for colloids. Okay? So, that's why we call colloids as intermediates of true solutions and suspensions. Now, let's differentiate again a solution, a colloid, and a suspension from each other. Again, intermediate ng solution and suspension ang colloid. So, it is based on the particle size. Diba? Again, it's 1 to 1,000 nanometers. So, guys, dapat memorize to. Okay? Possible na tanongin to sa board exam. Diba? And then, in terms of filterability, so colloids, they cannot be filtered. Solutions, of course, they cannot be filtered, but suspensions, they can be filtered. In terms of settling, so for solutions, the particles do not settle. Ganun din for colloids. But suspensions, the particles settle when they are made to stand. And then, the particles are not visible in solutions. For colloids, it is not visible to the naked eye. Pero for suspensions, it is visible to the naked eye. And then for light transmission, again, for solution, light passes through clearly, diba? For suspension, light is blocked. There is no transition. For colloids, however, we have the Tyndall effect where partial light passes and some of the light will scatter. Now, these are the types of colloids depending on the dispersed phase and the dispersion medium. Okay, so when we say dispersed phase, guys, the substance, it is a substance that is distributed or scattered throughout another substance. Okay, so it exists as small particles, droplets, or bubbles. Again, sila yung nasa scatter na particles or distributed sa isang dispersion medium. So, you can compare this to a solute in a solution. Parang siyang solute ang dispersed phase mo. So, kunwari, so milk, yung fat droplets, yun yung dispersed phase. Okay? Pag sinabi natin dispersion medium, it is a substance in which the dispersed phase is spread or suspended. Okay? So, parang yun yung solvent in a solution. Kumbaga, again, dispersion medium, parang solvent. Okay? So, for example, sa milk naman, water is the dispersion medium. Okay? So, again, the colloids can be formed either by dispersion or condensation. So, the following table describes the various types of colloids. So, if you have a solid dispersed phase and solid dispersion medium that forms solid sols, ang example natin yan ay ruby glass. If you have a solid dispersed phase and a liquid dispersion medium, you form a liquid sol. Ang example natin yan ay gravy, muddy water, and paint. And then, if you have a solid dispersed phase, again, parang solid solute, and a gas dispersion medium, let's say gas yung solvent, you have an aerosol. So, for example, guys, smoke, dust, they are aerosols. Okay? They are colloids. So, dapat guys memorize to, okay? Pag solid, 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 solid liquid, liquid, solid gas, aerosol. Next, if the dispersed phase is a liquid and you have a solid dispersion medium, you form a gel or a solid emulsion. So, for example, jelly, cheese, water, pearl. And then, if you have a liquid dispersed phase and a liquid dispersion medium, so liquid, okay, you form liquid emulsion. Ang example natin dito ay si mayo, milk, and cream. And then, if you have a liquid dispersed phase and this time a gas dispersion medium, you still form an aerosol. Pero ang example natin dyan ay iba. So, example ito ay mist, fog, and clouds. So, di ba sa clouds, it makes sense, right? Yung gas is a dispersion medium, tapos yung dispersed phase, yung solute mo ay yung tubig sa clouds mo. And then, lastly, if you have a gas dispersed phase and a solid dispersion medium, you have a solid foam. Example ito ay meringue, marshmallow, pumice, okay? And then next, for gas dispersed phase, and this time you have a liquid dispersion medium, you have a liquid foam. Example ito ay whipped cream and beer froth. Ayan. So, these are the characteristics of various or common colloids. Okay? So, for aerosols, these are formed again when solid particles or liquid droplets are dispersed in air. O, diba? Dispersed phase mo ay ang solid particles or liquid droplets. Tapos, ang dispersion medium mo ay gas. And they are of colloidal size. Next, foams naman, they are formed by trapping gas in a solid. Okay? For example, si pumice. Or you trap gas in a liquid. So, for example, whipped cream. Okay? So, meron kang mechanical or natural agitation na involved. And then, for emulsions, guys, these are formed by mixing immiscible liquids kagaya ng oil and water. And emulsifiers ang ginagamit to stabilize the emulsion. Okay? Next, gels naman, these are formed when a liquid ay nilagay mo siya into a solid light network. So, solid ang dispersion medium mo, then liquid ang dispersed phase. So this happens when you form gelatin and cheese. Okay? No, ano nangyayari to? So gels, they typically start as a solution and then they will eventually solidify. And then lastly, the salts, they are dispersed solids in liquid. So basically guys, solid on dispersed phase, liquid on dispersion medium. So meron tayong two types. First is the lyophilic salts and the second type is the lyophobic salts. Okay? Again, aerosols, they are easily formed as long as the solid or liquid particles are of colloidal size. Okay? For example, ito, dust carried by the wind and chemicals sprayed from containers. And then foams, again, they can be formed by introducing a gas in the solid structure or in liquid. So, guys, yung fixin nyo, foam yan. So, mag-introduce ka ng gas sa isang liquid. Ganon. Okay? Very cool, right? Next, emulsions can be formed by the dispersion of liquids that are initially heterogeneous. So, ito guys, mag-mix ka ng, for example, oil and water together. Okay? So, kailangan mo mag-add ng emulsifiers in order to stabilize the emulsion by retaining the colloidal size of the dispersed liquid. Okay? So, share ko lang guys, nung sa old job ko, grabe, natuto akong gumawa ng emulsion and how to stabilize emulsions. Kasi syempre sa old job ko sa King Cross, you have to make lotions, right? Kasi may lotion din sila. Tapos grabe, yun ata yung pinaka nahirapan ako sa lab. Okay? Syempre guys, dapat same temperature lagi ang oil and water para ma-form mo sila together. And of course, you have to add an emulsifier. Very important pala talaga yung emulsifier, guys. Kasi once minix mo yung oil and water, tapos wala kang emulsifier, magsaseparate talaga yan automatically. Tapos wala. Lahat ng pinaghirapan mo para sa oil phase and water phase mo, wala na. Ganun. Okay? So, very gandang experience ito sa lab, ang formation ng emulsion. It's very challenging. And ang weird thing is, never ko siya na-experience sa lab nung undergrad. So, parang, ayun, very eye-opening for me. So, sana guys, ma-experience or sana na-experience sila before sa lab. Ayun, nag-cheat ka. Okay? Now guys, emulsions, they can become unstable over time. So, pwede silang mag-clump muna, yung nangyayari sa flocculation. Tapos pwedeng mag-layer sila, kagaya ng sa creaming. And then they will eventually merge or coalesce, kaya dito. And that leads to their complete separation, which is breaking. Okay? Ito yung ayaw natin mangyari sa lab, guys. Dati nung nag-lab pa lang, oh grabe, ito talaga yung kinakatakutan ko. Pero syempre guys, never pa naman nangyari yun. Okay? So, ano ba nangyayari sa mga types of instabilities na ito? Okay? So, let's describe them one by one. So, first, in flocculation, dito, the droplets, mag-group sila together, pero hindi pa sila mag-merge, okay? Para silang loose cluster of drops, okay? Separate sila, pero close, okay? And then, we have here creaming. Now, in creaming, guys, yung mga droplets nyo, mag-rise sila or mag-settle para mag-form ng isang single layer, okay? And that is because of the difference in the densities, okay? So, ang mangyayari dyan, guys, yung emulsion, mag-separate siya into layers, pero yung droplets na yan, okay, magiging intact pa rin, di ba? And then, next, we have the coalescence. So, here naman, guys, mas malala to kasi yung mga droplets nyo, mag-merge na siya to form even larger drops, okay? Then mo malalaman, guys, na hindi na stable ang emulsion nyo because that will eventually lead to the breaking or the cracking of the emulsion. So there, your emulsion will fully separate into two distinct layers. So yung oil nyo will separate from the water layer. Okay? And guys, check ko lang, irreversible ang breaking na yan. Hindi mo siya ma-restore just by shaking again. Based on experience, guys, again, hindi mo siya, hindi mo ito masasalvage. So kailangan mong ulitin ang buong emulsification process. Okay? And then here we have gels. So gels, again, they start with the liquid solution, then eventually they are allowed to solidify, usually at a certain temperature. So here we also describe these two types of liquid salts. So first we have the lyophilic salts. Again, they are stable, solvent attracting, and they form protective layers. Well, lyophobic salts, they are unstable, therefore they require stabilization. Okay? So guys, for example, we have a lyophobic salt. Okay? Tapos gusto natin na mag-coagulate siya. So if you want to coagulate our lyophobic salt, then we add an electrolyte to our lyophobic salt. And dahil dyan, precipitate will form. Okay? Next. Let's say guys, ayaw natin magkaroon ng coagulation for our lyophobic salt. So ang gagawin natin is to add, aside from the electrolyte, mag-add tayo ng lyophilic salt. Okay? Okay? Therefore, if you add a lyophilic salt to your lyophobic salt, because of electrolytes, no precipitate will form. Okay? So this differentiates lyophilic salts from lyophobic salts. So in terms of the ease of preparation, okay, mas madaling mag-prepare ng lyophilic salts. Okay? However, for lyophobic salts, mas mahirap siyang gawin. For stability, again, lyophilic salts are very stable, hindi sila nagko-coagulate because they are solvent attracting. Okay? They are solvent loving. However, for lyophobic salts, they are less stable. Kaya mas madali silang mag-coagulate in the presence of electrolytes. And then for lyophilic salts, they are reversible. Okay? For lyophobic, they are reversible. Okay? For lyophilic salts, the particles are well solvated. Mas madali silang nakakover ng solvent kasi solvent attracting sila. However, for lyophobic salts, there are no solvation of particles. Okay? So lyophilic salts, their viscosity is higher than the pure solvent. But for lyophobic salts, their viscosity is the same as a pure solvent. Tapos surface tension naman, lyophilic salts lower than the solvent, or lyophilic salts same. Okay? Ang example ng ating lyophilic salts guys are starch, gelatin, gum, and proteins and water. Pag lyophilic salts naman, example natin ay metals, metal oxides, and metal sulfides. Okay? Take note of that, guys. Again, lumalabas din sa board exam ang about sa lyophilic salts and lyophobic salts. Okay? Now, we have this concept we call the gold number. Now, the gold number quantifies the protective power of lyophilic salts. Guys, bakit may protective power ang lyophilic salts? Again, when you add lyophilic salts to your lyophobic salts, it prevents the coagulation of your lyophobic salts. So, gold number is formally defined as the milligrams of the lyophilic salt that must be added to 10 milliliters gold salt in order to prevent the coagulation of the gold nanoparticles when 1 milliliter of 10% NaCl solution is added. So guys, what does that all mean? Okay, yung gold salt, yun yung lyophobic salt nyo, right? Again, examples ng lyophobic salts are metals, right? So yung gold salt, yun yung lyophobic salt nyo. Now, gold number is the milligrams of the lyophilic salt na idadagdag mo sa 10 ml gold salt. Okay? Para i-prevent ang coagulation gold sol into, in order to prevent the coagulation of your gold sol, specifically the coagulation of its gold nanoparticles when 1 ml of 10% NaCl solution is added. So guys, bakit nag-add ng 1 ml of 10% NaCl solution? Let's recall, diba, when we coagulate a lyophobic sol, we have to add electrolytes, right? Kaya ka may 1 ml of 10% NaCl solution dyan. So guys, just memorize this definition. Okay, again, it quantifies protective power of lyophilic sol. So, a greater gold number indicates weaker protective power. Meaning guys, kung greater yung gold number mo, then you would need a larger amount of lyophilic sol, more milligrams of lyophilic sol, in order to protect the lyophobic sol from coagulating. Kaya ka may weaker protective power. So, a higher gold number, so a lower gold number guys, means stronger protective power. Meaning yun guys, kailangan mo lang ng less milligrams of the lyophilic sol in order to protect the gold sol from coagulating. Kaya low gold number means higher protective power. So, gelatin guys, it has a low gold number, meaning it is very effective in preventing coagulation. And it has a high protective power. Meanwhile, gum arabic here, it has a higher gold number, meaning it is less effective in preventing coagulation. Plus, it has a weak protective power. Okay? Yeah. So, I hope it's clear, guys. Yeah. Ayan. So, basta na guys. Basta na for PChem. Tapos tayo sa ating crash courses. Okay? So, sagutan nyo guys. Ayan, number 1. It occurs upon absorption of visible or ultraviolet light. Thus, such reactions require light to form products. Yes, that is your photochemical reaction. Next, it is the number of molecules reacted or formed per photon of absorbed light. Any guess? Ayan. Tama. This is the quantum yield. Next, it involves adherence of particles to the surface of solid. Yes, that is adsorption. Next, in this adsorption isotherm, ideal gas absorbed is a monolayer on the solid surface. Oh guys, sino kaya yan? Tama, that is Langmuir adsorption isotherm. Take note guys, ideal gas yung kinoconsider sa Langmuir isotherms. Because, again, we assume that there is no interaction between the gas molecules. Okay? And in a Langmuir adsorption isotherm, we assume that there is a monolayer, diba? Uniform layer of solid surface. And lastly, these are mixtures that have dispersed particles larger than solutes, but smaller for the mixture to become heterogeneous. Any guess? Tama, that is your culprit. And yay, we are done with physical chemistry, guys. So congratulations. You have made it to the end, diba? And so you are now ready to answer practice test 10 for 20 minutes. Okay? So guys, again,